So Roger just gave a very, very quick overview of the speech technology from the basic technological development perspective, which is to say the push side of the equation. Basic technology being pushed upward to application developers and others. I'm taking the opposite approach and discussing the work that I do with EIG in developing practical systems that are commercially viable and that appeal to end users in their sort of natural habitat. And therefore I have a different perspective on the technology requirements and on the value proposition. And intelligent speech is indeed the goal. The challenge becomes, how do we define intelligence and what are the practical applications for intelligence in dialogues? There has, in fact, been some effective technology transfer. Certain niches are succeeding commercially. Sadly, the main niche that is successful today is the interactive voice response niche. That's the telephone service applications that Roger was alluding to. The reason it's successful is because the end users do not choose to use the technology, they're victims. The enterprise chooses to use the technology in order to save the cost of the human agents. And therefore the victims, the users of the systems, by and large, as over many, many years of these systems have learned behaviors that I'm sure you're familiar with. The leading user behavior interacting with an IVR system is pressing 0 over and over again to bypass the system and get to a human being. That's unfortunate, but there are, in fact, a number of these systems that have been well designed and that work very effectively, and the users actually prefer them to the human agents. And so we are seeing some trends there. The main conflict that drives design is a conflict between the two philosophies that I'll discuss in just a moment. The philosophy of building systems that attempt to emulate human capabilities, the anthropomorphic model, and the systems that choose to bypass that model and say instead we can use speech technologies that behave in very different ways than the way humans behave and yet can achieve some practical results. And the conflict between those two philosophies is an important one to understand. Application development is inherently interdisciplinary, and I think one of the main problems in the industry over the years has been the inability of the entire ecosystem to find communicative bridges between the various groups and find ways to build systems that, that take advantage of all the different stakeholders that are playing the game. Speech is in general a multi-tiered market, which means that we have multiple layers of distribution and a very complex web of buyers, users, value-added resellers, and I think that's the main reason that we've seen so many stumbles over the years. Adam Smith's invisible hand is tied with the speech market because the buyers and the users are not necessarily the same group. So the feedback loops that normally make technology either die or succeed are not as active in speech recognition, and I think speech synthesis as well. And some of the lessons that we've learned, I suspect, are going to be applicable to other fields represented in this room: robotics, intelligent technology in general, cognitive systems, cognitive solutions. Sellers don't know what they're selling. The people who built the technology aren't in the room selling the technology to the end user. It's salesmen that are in the room selling the technology, and they say the things that Roger described. The buyers absolutely don't know what they're buying. They've formed superstitious beliefs about what the technology is, how it works, how easy it is to develop, tune, and tailor, and the mismatch between end user expectation and the capabilities of the technology are swept under the rug. Demand itself is quite abstract, and that's why disappointment tends to be high with these systems. And that's why the most successful strategy to date is the selling the future strategy. You don't win by going to your buyers and saying, well, this stuff really doesn't work very well, but it's the best we've got now. So buy it and then wait until next year or the year after that and it might get better. You don't make a sale that way. What you do instead is say, this is the wave of the future, and this is an exciting and innovative new opportunity for your company to differentiate itself from others. And there we are now, sliding right down that, what did you call it, Roger? The Promises Avenue. The key issues here are the anthropomorphic versus the mechanomorphic design philosophies. Product designers tend to prefer the first because it's sexy and it's future-oriented. End users tend to prefer the second because it's easy to understand and it works. The mismatch between those value propositions becomes fatal with a lot of products. There's also a great deal of cultural conflict throughout the ecosystem between especially the very low-level speech labs, the sort of priesthood that's responsible for making the broad decisions about the architecture of the systems, the capabilities of the APIs, the manner in which the tools themselves are delivered upward to the developers. They speak a different language. They have a different value system than the people at the top of the value chain who are trying to get something done practically. And so you tend to get, yesterday's term was TRL, the technology readiness level. The stuff at the bottom tends to not be as ready as the promises upward to the developers, and therefore we end up using the end users of the latest generation of application as the guinea pigs. And a lot of that revolves around enabling versus enhancing applications. Design tools are the main thing I'm going to emphasize today, and then I want to close with this concept of the conversation, in quotation marks. The conversation, in my opinion, is finally beginning and reaching the public at large, and that conversation is going to be transforming, I think, in the next 5 years for all of us in our respective industries. The big question that we ask, that I ask specifically when I'm consulting with clients about to build a speech application, is, what are you trying to do? Are you attempting to build a real, conscious, sentient entity, one that can have an effective, spoken, natural language conversation with end users? Because if you are, then the user trusts the system and believes what the system says and how the system behaves because it's true. I'm actually communicating with a conscious entity that loves me and I can love her. And we can form a relationship that's a lasting relationship. As I explore the system, the interaction gets deeper and deeper. And I can discover new things emotionally and in very human terms as I talk to and listen to the system. There's more there than I can ever discover. It's a very exciting promise. Or, as we heard earlier this morning, are we building a convincing simulation? It's human-like. It's human-like in every way. Maybe it even passes the so-called Turing test, which I think we all agree has become pretty much irrelevant in the modern-day world. If that's the case, then the user believes because the illusion is compelling. It's like going to the theater. I'm watching a drama. I know that the man on the stage did not kill that woman on the stage, but I'm crying anyway because I've suspended my disbelief and I'm interacting with a certain trust that the system itself is going to effectively deal with the trajectories of emotions and the human realities that we're together conversing about in a way that's not going to betray me. As I explore this interaction, however, it actually becomes more shallow, doesn't it? This is what we're seeing today in our usability tests with Siri. She's great fun at first, and then her repetition, the sameness of her replies, the shallowness of the interactions. How many things do I want to have her give me a simple definition of without subsequent explanation? As I explore, the terrain becomes familiar and the magic disappears. If we're building a convincing simulation, we've got to find a way to sustain the magic. We heard an example earlier about Mickey Mouse this morning. Mickey Mouse, we go to the movies and we watch and we laugh. Suppose Mickey lived in your home. We would rapidly tire interacting with Mickey. We'd discover that Mickey is just a superficial cartoon character. He has no substance, he has no depth. Every one of the instinctive emotions that we as human beings have evolved over the years begin gradually to resist, to reject the solution. Or, here's my third option. What if I want to build a product that actually does something for people, a product that has a value proposition, a product that delivers results that in and of themselves have value, regardless of the fact that I'm using a speech interface rather than a graphical interface or a tactile interface to drive the product. Well, in that case, the user suspends disbelief because it's convenient and useful. And the user focuses on the utility and the task, not on the interface itself. As the user explores the interface, the user's sense of power and control over the product grows. And that's the model that I prefer when I'm encouraging customers to build practical products that exist today based on today's technology, rather than the promise of some imagined technology of the future. The top two are anthropomorphism. The bottom one is mechanomorphism, using speech technology to solve a real practical problem regardless of whether it's human-like. And so we use the word natural language, and I always like to put that word in quotes because, in fact, we human beings use all different kinds of language when we're interacting with all kinds of entities. When you converse with your boss or your spouse or a store clerk, when you speak to children, when you interact with your pets, or talk to a foreign language speaking person, that's a classic example right there. You talk to the taxi driver. He doesn't speak your language, nor you his. And yet, you've got to communicate with him. And what do? You speak more slowly. You fall back onto verbs and nouns. You put spaces between the words, exactly like Roger said speech systems used to do. And you wave your hands a lot, don't you? And preferably, you write things down on scraps of paper and hold them up in front of him. Pigeon language in certain work settings is an especially important phenomenon. When you study the speech behaviors of a workforce in Hawaiian sugar plantations at the turn of the century, for example, you discover very, very natural, regularized use of spoken language spoken by people who are not the native speakers. In other words, set and setting changes our behavior. And if we need to get the task accomplished, we adjust our speech to the requirements of the machine. And the theory of mind, therefore, becomes critically important. This points directly to what we were hearing today about mirror neurons and the theory of mind. When a user interacts with a computer by voice, the user forms a theory of the machine's intent and the machine's capabilities, and changes her behavior based on that theory. You see people all the time talking to speech recognizers, slowing down their speech, hyper-articulating, explaining things aggressively. Many people with natural language systems underspecify their speech. The machine very happily says, "How may I help you today?" And the user goes, "Inquiry," in the hopes that perhaps that keyword will trigger something. They don't know anything at all about keywords. They don't know anything at all about grammars, about states, state transitions, which always confuse users. And so it begs the question, what is a human-machine pigeon? And is it possible that that over time will become a new way of talking, that human beings reserve only for talking to non-sentient machines? And that, in fact, it's not like humans speak to other humans. It's the way we as human beings have learned to interact with the intelligent machines in our society. So with that in mind, let's quickly look through the markets themselves. An enabling application is an application that, in the absence of speech, you can't accomplish the task. That would be, for example, screen reading for a blind person. You have to use speech to accomplish the task. The user is blocked from those functions without it. The technology opens up new tasks that were before impossible. Eyes busy, hands busy, such things as that. An enhancing application is one in which the user can perform the tasks right now. I can send a text message with my thumbs on an Android. But if I can speak the text message and send it, there's an enhancement of some kind. Perhaps it's faster or easier or safer. So with that in mind, I'd like to go down and just quickly give you this. I am aware of the passage of time here, but I think that I just want to very quickly show this. Oh, I can't open it. Sorry. It's not worth it to hunt it down, Roger. It'll be okay. This is a PDF file that I'll make available during the workshop today for those of you that are interested. It describes all of the current markets for speech technology, which ones require very intelligent technology, which ones require more deterministic kinds of dialogue designs and can survive on smaller grammars, which ones are enabling, which ones are enhancing, which ones require speech output as well as speech input, and so forth. The missing layers are the key piece in my view. We have a technology vendor on the left, and we have demand on the right, and there's a big pipe. This is why we use the words push and pull. The technology vendors on the left are pushing technology into a pipe, and the pipe gets all clogged up. But if there's nobody pulling on the other side, then the technology never gets transferred. What's missing and what's clogging up the pipe is product design tools. We build these fabulous speech interfaces. The priesthood puts together the acoustic models, the phonetic speech models, and builds an API and development kit and pushes that into the pipe. Now, some people just above them, smart people, are able to learn how to write grammars, how to weave together the dialogue, how to use dialogue managers in order to construct effective spoken stimulus response kinds of dialogues. But at some point, somebody enters the value chain that does not have the kinds of skills that are required to build language. They're artists. For example, the people that work at Pixar and want to use text-to-speech to let a character talk. They're artists, not speech scientists and not technologists or engineers. They don't have the tools they need to be able to build these applications in the kinds of variety and numbers that we need to get frequent daily end-user experience with the technology, and it's stopping us. So the ecosystem is one that we have to look at from a pull perspective. There's a technology layer, an applications layer, and an end-user layer with distribution through channels. At the bottom are the base technology people, and they build kit and tools, and they, of course, communicate sometimes extensively with their academic colleagues. They come to conferences like this one. There are standards committees and standards bodies, a lot that's happening down at that level. At the applications level, we've got application developers and system integrators and value-added resellers. And then at the top, of course, is where we start to get into the selling and distribution aspect of the thing. Way up at the top are the end users. Now, the ones that actually produce the speech signals that have to get recognized and listen to the speech signals that are generated in response to the recognition. And all of these systems, of course, connect with each other. And we can simplify that whole value chain by using this simplified model right here. The VARs and the application developers don't have good tools. And they're too close to the market to think theoretically and to think abstractly. But they're not close enough to the technology vendors to really understand what the technology is doing and how to manage it, how to affect real solutions. There's one slightly different model, and that's the IVR model, because the enterprise stands between the end user and the development of the technology. That's the value chain simplified. Now let's talk a little bit about robots. Robots, I think, are going to be driving a lot of the new innovations in speech technology because we have some significant reasons for why we need to talk to robots. rather than use our iPads or our smartphones to control the robots. And home robots, social robots, are the ones that are the most abstract in terms of demand. So I bring up Jibo. Jibo is just one example, of course, of many of these kinds of robots. And has been a bit on the trendy side in the US for a product that hasn't yet been released. And there's the danger that there will be a disconnect, as there often is, because what Jibo actually does is take pictures of the family, read email, report a few facts that are available from the web, and that's it. But to the president and the people at MIT that are really getting behind the product, what Jibo really does is establish a personal and human relationship with you, living with your family, reading stories to your children, getting responses from the children while reading the stories. It sounds like a disaster in the making, doesn't it? Another example of Promises Avenue. But I'm actually optimistic. If not this product, then many like it over the next few years. And here's the reason. It's not just a product, it's a platform. And if they do their job right, that platform will include tools that third-party application developers will use to build apps that run on Jibo. So just like you buy an iPad and it doesn't do much for you, but you start downloading specialized apps that are unique to your challenge from the App Store, and they're cheap. And they're all well-built. Many of them, I should say, are well-built. And they do interesting things, very specialized things. None of them set the world on fire, but the ecosystem is very healthy, so a lot of people buy the enabling platform and then go and browse around the App Store to see what it does. If Jibo can trigger that kind of a response, then for the first time, we'll have in people's homes devices that you consistently interact with by voice, doing lots and lots of different things. But each thing will be very simple, easy to learn to use, and very rewarding for the end user, and people will begin getting experience with talking to machines, which those of you that have talked to machines know is quite awkward. Even though we use the word natural to refer to it, it's actually quite awkward. So we're modeling it after the iPad, and if we get a lot of variation quickly, then we'll start coming across Jibos. They'll be at your bank when you go into the brick and mortar bank to help you filling out your applications or things like that. They'll be at the waiting room in the medical clinic. So instead of being handed a piece of paper with a clipboard, you'll sit down next to Jibo, who will then extract your medical information, put it in a form, put it in a record, basically driving the dialogue, asking you questions, filling it in, asking you to read it and make sure that it's correct. Pretty simple stuff, but in a way that makes you comfortable that you are not talking to a machine that's so smart you have reason to mistrust it. Instead, you're talking to a machine that's just smart enough that you have good reason to interact with it. And you're rewarded, therefore, for that behavior, and you'll engage in the behavior again. I wouldn't be surprised if we didn't start ordering our fast food more and more. Is it time here? I'm almost finished here. This is the conversation that interaction will trigger, the tribal conversation, which really is at the heart of our industry here. If we're building intelligent machines, those machines have to live in human society. And humans are mistrustful of new, powerful, intelligent entities. So the machines have to infiltrate our society cautiously and safely. Otherwise, it becomes us versus them. And we've seen the movies, haven't we? This has all been discussed in the movies. What happens if the machines step outside of their relegated boundaries? The issues are really philosophical. The question here is, does a conscious machine diminish human worth, human value? And if it does, why are we building them? That's the question that the common average layman is going to ask. What is intelligence if we build machines that are intelligent but not conscious? Can humans learn to accept such an alien intelligence? And if so, how do they behave? How do we talk to them? How do they talk to us? What are the rules of engagement for these machines? What are the observable, externally observable behaviors that are associated with that conscious entity, or that seemingly conscious entity? So the question here, which are you building? The real thing, the simulation of the thing, or a mechanomorphic product? The answers are, if you're shooting for number one, you're not going to get there anytime soon. If you're shooting for number two, you can get there today, but you're in the arts and entertainment business, not the productivity business, and so you'd better do a good job with your arts and entertainment. If you build somebody like Mickey, and he's cool, you'll win. And if you build something that is less cool, then you'll fail quickly. Design philosophy number 3 is the primary success in today's speech market. Dragon, naturally speaking, is a perfect example. No anthropomorphism, but an effective and useful product. So over the next 5 years, we'll watch this pigeon language evolve, and the conversation will grow and deepen, which means that as it becomes more emotional, it becomes more political. And that's going to directly affect our funding, and it's going to directly affect the popular conceptions of the work that we're doing. If we get it right, then we can ease machines carefully and cautiously into our society. If we get it wrong, then the tribal backlash is going to be our biggest problem. This is, from my perspective, focused on the pull side of the equation. So thank you very much.